Welcome to the Siemens PowerMod Competitor Comparison class. This 16-minute video will take you through the basic installation steps for a common PowerMod module and discuss the features that PowerMod offers versus the competition. These features add up to as much as 40% labor savings. Please see your Siemens sales representative for documentation on PowerMod's labor savings and features. We hope you enjoy the video.
Every Siemens device, every PowerMod Siemens device has bands around a two-piece carton. So the advantage of this is when you get ready to take the devices out, you don't have to slide them out of the tube. You just simply lift the top off and lift the device out of the box. Saves you a lot of time rather than having to slide it out of a tube-style box that we saw with the Square D device. Okay, what you're looking at is the interior of the breaker main. Now notice the bottom of the enclosure has knockouts already in the bottom, and the bottom is not removable. This means that you would have to align the conduit to exactly the KO configuration on the bottom. As we pan up, notice there is no provision for a compression lug landing pad to be installed in the field. You would have to order that as a separate catalog number from the factory direct, and you could not change it once it is in the field. So what you're looking at is the bottom of a 400 amp WB series circuit breaker main for PowerMod. Notice on the bottom that the bottom plate is removable. There are 6 screws holding that plate in. It is blank. The purpose of this is so that you can go ahead and put the device on the wall and run the conduit into the bottom without having to arrange the conduit in a particular pattern to match up to a KO configuration that we've pre-populated. So this way you can remove the plate, pull the conduit through the bottom, and then knock whatever KOs you need out of the plate on the bottom. The device is overhead or underground feed, and as you can see is set up for standard mechanical type connections on the bottom side of the breaker. What Steve's demonstrating here is the ability to convert this main from a mechanical to a compression lug setup. So what he's installed is what we call a lug landing pad, and as you can see that lug landing pad attaches directly to the load side of the breaker. When you attach the lug landing pad, now you've got a NEMA 2 stud pattern configuration on the bottom side of the breaker that allows you to connect compression lugs if the utility requires it. The difference from Siemens versus our competition is that this kit is even available. If you were to need compression lug capability from the competition, you would have to custom order a special part number for the entire main, so you'd have to get the enclosure set up for compression lugs from the factory rather than installing an optional accessory in the field. So what you're seeing is what we call the phase bus. So you've got A, B, C, neutral. That's 4 connection points that have to be made. The connection points are made internal. In other words, once these covers go on, you have to take the covers off in order to access the connection points. Each one of these connections has what we call a torque indicating nut. That means when it gets to the proper tightness, this outer piece that's on top of this red disc will twist off. When you slide these 2 units together, this side must go into this side, and you make your connections internally, as I said before. So at this point, the 2 devices are together. As you can see, your connections are internal, so that means that these covers have to be removed in order to access them. Second thing is you can see the connections are made directly on the busing. So that means that after this product is energized, these connections are live. You can't touch them without using insulated equipment or tools or cutting the electricity off to the product. What you're looking at is the left side of the 125 amp meter stack. Again, this is very similar to Square D, where you've got 4 individual electrical connections that must be made and a separate bonding and mechanical connection. This is the side of the 225 amp meter stack. It's the receiving side for the bus bars that you saw sticking out of the other side of the 125. Notice that the pre-positioned nuts that are there to make the connections do not have torque indicating nuts like we saw on the Square D model earlier. You're looking at the inside of the 225 amp meter stack after the connections have been made. Notice the electrical connections are inside of the stack. They are not externally accessible. Also notice that you do not have torque indicating nuts on the phase connections as we saw earlier on Square D. Also notice that one of the connections is placed behind the black meter socket in the center of the screen. As you can see, that device would need to come out in order for you to make the proper connections inside of the device. What you're seeing are the electrical connections in between the PowerMod meter stacks. So You've actually got A, B, neutral, and C is the phase bus arrangement. All of your connections are here, and your bonding point is actually going to be connected via this bracket in the back. So this is the quick connect. On the back, you see there's an oversized bolt head on the back. That's going to actually go behind that last bracket on the right-hand side of the screen. And so Steve's going to insert the quick connect, which is going to instantly connect the A, B, C, neutral, and bonding connection points for this meter stack. One of the major advantages that you're looking at is that connection point, as you can see on the nut on the outside, is insulated. In other words, it will not be live after the device is energized. And it's also externally accessible so that you can access the device without having to take covers off. So it's a huge safety feature that you can come back, check your connections without having to worry about cutting power to the device. See, notice on this side it's an identical twin to the left-hand side. So there is no right or left sides because all the connections are internal inside the stack, and the major connection point for connecting everything is in between the devices. Okay, we're going to push the two stacks together, and what it's going to do is make instantly the electrical, neutral, and bonding connection points between each device. In the mechanical connections, on this particular product, you've got 3 main bolts, 1 at the bottom, 2 at the top. As you can see, these bolts are not straight. So this device is mounted directly next to this one. In order for the bolts to go into this device, they have to be perfectly straight. So this bolt, as you can tell, is tilting down. This one's tilting up. Therefore, when you do slide these devices together, the bolts are not going to automatically protrude through the other side. The user is going to have to find a way to get their hand in this very tight space and try to push the bolt through, hoping that the holes are lined up. So what you're looking at are 3 connection points, 1 at the bottom, 2 at the top. You've only got 1 type of hardware to use. With Siemens, you'll have 2. And third is that, as you can see, there is what we call a star tooth washer under each one of these hex nuts. Now, the point of that star tooth washer is it has to grind the paint off the enclosure. In other words, you have to physically scratch into the paint. That degrades the paint quality of the device. This is the right-hand side of the mechanical connection. Notice the plate is pre-positioned and stationary, meaning that if the holes do not line up, then you would have to manipulate both enclosures in order to get the left hole to line up with the right hole. So the quick bolt is retained for protection during shipping. That way it doesn't get damaged. It's held in place by attaching these plastic straps in between the spring and the channel, which holds the bolt in place. So Steve will now go up and pull the strap out and demonstrate how the bolts come out. So as you can see, the bolts instantly protrude through. They are spring reloaded, so Steve, if you could push one of the bolts back in just to demonstrate that. So if for some reason these 2 stacks don't line up and you need to manipulate them to try and get them to line up, the bolts will automatically recede back into the device until such time they do line up, and then they'll protrude through on their own. So as you can see on the right-hand side, the holes are oversized for the bolts that are on the left-hand side. So the holes are twice the diameter that they need to be in order to make it easier to get them through. The other thing is that the gasket is cut out, so you don't have to worry about trying to push pieces of gasket through in order to make room for the bolt to come through.
Go for it.
What you have is all connections are facing out. That's a positive. All connections are using a Belleville washer. That's also a positive. Each one of these devices is what we call field phasable. As you can see, we've got A, B, and C bus bars, and you can rotate these straps from A to B to C to phase any one of these devices on either A, B, BC, or AC. Okay, so what Steve is going to do is he's going to loosen the first piece of hardware. He's going to rotate that strap over and put it on the A phase so that it's phased on A. And then he's going to have to reposition the nut and retighten. As you can see, there's nothing in the area providing him what proper tightness setting these connections should be at. All right, so what Steve's going to demonstrate is when you have to access the field phasable connections, you have to take the socket out. Notice that the socket plugs on, it does not bolt on, so you have no way of indicating whether the connection is valid or good or not. Steve will now show where you would have to change the phasing in order to phase the entire meter stack. Note you cannot phase each individual position. Instead, you have to rearrange multiple connections behind the vertical bus and make different connections to the horizontal bus. This requires loosening at least 3 to 4 bolts and repositioning these straps, which is a very time-consuming process. What Steve's going to do is he's going to rephase this position from BC to AC. And notice what he's doing is simply loosening the hardware. He's not removing the hardware. That's not required in order to complete the action. So he's going to reposition the strap from the B over to the A phase. And he's going to retighten the connections. Now, Steve automatically knows how much to retighten the connections to because that information has been molded into the socket for him. Okay, so you're looking at the bottom of the enclosure. Notice there's the same KO rings that we saw in the 400 amp. The point that we're going to be making here is the back of the Siemens device is removable. So again, it's easier to bring the conduit and cable into the back side. What you're seeing is the neutral. The neutral's in the center of the stack. Now note, you can bring cables out of the top or out of the bottom, but the neutral's always in the middle. So you can't really move it in order to decrease the amount of wire that you need to wire this thing with. So the ground is mounted on the bottom. This is where the grounding points for each individual position would be made. Notice it's on the bottom. You cannot relocate it to the top. It does have extra provisions for mounting additional ground lugs if necessary, but if you are exiting out of the top, you don't have the option to move it to the top. This is a 225 amp breaker position for square D. Notice that the breaker bolts into place. Notice also that there are a lot of connections made from different parts of busing to move from the socket side over to the breaker side. So all in all, you're looking at about 6 connections in this device for each individual position. Okay, so in this device, if you needed to use a 125 amp breaker or lower, you have to use a conversion kit in order to do it. This conversion kit, as you can see, adds even more connections in the current path from the socket to the breaker. It also takes an additional time per position that you have to go through and install the kit and tighten the connections. Notice also that the breaker is now angled and not straight. So what Steve's doing first is he's going to plug in the 125 amp breaker. So all that's going to do is plug in that same kit that he just installed. The second breaker, which is the 225, he's going to have to bolt into place. Now note, this adds another connection point, plus he's got an added extra installation time in order to put the breaker in and tighten the connections down. This is the back of the Eaton color hammer meter stack. Notice that the KOs are pre-punched. There is no removable plate, so you would have to use the knockouts that are provided and twist and turn the stack in order to get access to the proper knockouts. This is the neutral in the Eaton color hammer meter stack. Notice that the neutral is in the middle. It is not relocatable to the top or bottom for top or bottom feed. It does not have provisions for additional neutral provisions should you need it. This is the Eaton color hammer ground provision in the residential meter stack. Notice that it is on the bottom. It cannot be relocated to the top. It does not have additional access points or additional lugs if you need to add them in the field. Steve will now show us how the breaker goes in. The breaker slides on. There are 2 bolted connections which are difficult to access on the top of the breaker. This must be made for every breaker installed in the device. Okay, so on every Siemens meter stack, the back is removable. So if you're coming into the back of the enclosure, rather than having to manhandle a 100-pound device and flip it over to try and get KOs out of it before you hang it on the wall, you can simply go ahead and put it up on the wall, remove the plate, knock the knockouts out, and then put the plate back. So this is the neutral in the residential meter stack, and as you can see, it's positioned on the bottom by default. But if you need to exit out of the top, you can relocate those neutral lugs to this top provision in this device. Okay, so this is the ground in this device, and as you can see, it actually has extra ground lugs provided in case you need extra provisions. It's also got a provision for an additional one. Again, if you are exiting out of the top, you can reposition this device up at the top of the meter stack. Steve's going to demonstrate first inserting the QS breaker into the stack. Notice the breaker plugs on, saving you the labor and time of the mechanical connection. Steve's also demonstrating installing a 100 amp breaker into the same 225 amp meter stack. So if you recall, with the Square D device, we had to install a separate kit in order to accomplish this function, whereas PowerMod has the default functionality to do this on every device. The QS breaker has connections on the side, meaning that you would make a single right-hand turn into the lugs of the breaker. This saves you the time and extra wire of having to make two separate bends to come into the bottom of the breaker. So Steve's going to push the device. Notice he's going to have to wedge it along due to the friction of the metal rail on the hanging unit to the rail on the wall. This is the back of the 125 amp meter stack. Notice there's just a plain rail. There is a hole in the center of the rail which provides additional issues for sliding the device along the mounted rail on the wall. Steve's going to demonstrate pushing the two units together. Notice he's got to use both hands and shove the unit together. It does not slide smoothly on the rail. So the quick roll, it has nylon-based wheels, so they don't corrode over time. It is held together by a stainless steel shoulder rivet, which essentially means that it's not going to corrode or rust. It has a duplicate spacing bracket, which allows you to keep the device spaced evenly off the wall. That's important because if it's at a tilt on the wall, then the screws down below are going to want to dig in. So that second bracket is spacing the bottom of the enclosure off the same amount of distance as the top of the enclosure. So what Steve's going to demonstrate is the quick roll feature, which allows you to press the units together with simple finger and hand pressure. You don't have to shove or grab devices or try to lift them off the rail in order to move them.
Thank you for attending the Siemens Competitor Comparison class for the PowerMod line of multifamily metering products.